Questions about the program number 0. So we had one issue with a student who's running a MacBook, right? So what are you going to do with that MacBook?
I'm going to use Xcode.
Xcode, okay.
And you can create there's a way to create like a C++ project. So
Okay.
I think that will work.
Okay, as long as you're not coding straight Xcode or Swift or anything like that. Might be a problem. All right. So you need a little more time to get that done. I take it, right?
No, Xcode is already installed. So.
But as far as to complete Project 0, when is the due date for the Project 0?
Friday.
This Friday.
Yeah.
So you have lots of time. Okay. Anybody have any questions about the project? Yes, David.
So the C compiler, do you use C98, C11, or C14?
I think
C17. It's a different version of C.
Yeah, it's a different version. So I've used 11 without any problems.
Okay.
If you have any problems, let me know right away. Okay. Anybody else? Any other questions? Okay. So last time we got to the point of pointers. So we started talking about pointers last time, and we talked about simple pointers, and we also talked about simple references. And we made a big distinction about pointers and references. In some ways they're the same, but in one important way they're different. Who can tell me what is the difference between a pointer and a reference?
A reference is already defined.
Okay, are you sitting in the first 3 rows? Go ahead, answer the question, then you can move. So go ahead.
A reference is already dereferenced.
So, not already, but a reference will be automatically dereferenced, but
A pointer is not.
a pointer will not be automatically referenced. So, if you print, so think about this. If you have a pointer to an int, okay, and if you have a reference to an int, if you print cout a pointer to an int, you will get an address. If you have a pointer p to an int and you cout p, you will get an address. Typically in hexadecimal, 0x, blah, 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 blah. If you print a reference to an int, you will get a pure value. Does that make sense? So that's a very good answer. Very good answer. Another distinction between pointers and references, anybody can tell me something else? Something about assignment into them. A pointer and a reference. Nobody? A pointer, you can assign something into a pointer and assign. You can assign different things to a pointer, which means you can assign different addresses to a pointer at different times. But a reference, what?
It's going to have a garbage.
Good, but speak louder.
It has a garbage value.
References all the same for
A reference has to be initialized and can never again be changed. So once you initialize a reference, that reference is to this memory address. And that's it. It's automatically different, that's all it does. So when you print the reference, you always print the value. When you assign into a reference, you're assigning into the value. You're never assigning and changing the reference. Okay, somebody else had a question or a comment? You gotta speak loud in here, because that thing, what is that thing? Oh, it's a fan. Huh?
It's coming from the back.
Yeah, and also one here. So I'm getting like a stereo effect here. Okay. Anybody else have any comments or something? Okay, so you get the idea, right? All right, so now the next thing we're going to talk about is something called star value. Star value. How big a star am I? Am I a superstar? Am I just a little star? So star value is this is the definition of star value. Star value is the number of stars or asterisks, whatever you want to call them. Stars are easier to pronounce than asterisks. Star value is the number of asterisks or stars you can put in front of an expression. The maximum number of stars you can put in front of an expression. The lowest star value is 0, when you cannot put any stars in front of an expression. And the highest has no limit. Of course, normally, you think maybe 2 or 3 would be sort of an upper bound value, unless you have some crazy pointers. So, star value. So if you look very carefully here, is, again, the way we say, if I say int star star q, q is an identifier. So that means that q is an int star star. Q, so that this is q is the identifier, and the type is int star star. So what is q? Int star star. Now, we don't like to say int star star, because people don't know what we're talking about. Typically, we want to say q is an int pointer pointer, which means it's a pointer to a pointer. When you dereference q, you will get an int pointer. You see, q is a pointer to int. So when you dereference it, you will get a pointer to int. When you dereference it again, you will then get the int. All right, let's see how that's going to work. Now, p is an int pointer. So p is the identifier. It's of type int star. What's int star? Int pointer. Q is the identifier. What type is it? Int star star. What's that? Int pointer pointer, or pointer to int, however you want to say it. K is an identifier. What type is it? It's an int, and it's initialized at 7. So you can imagine K is a memory location with a value of 7. Now, the address of K is being assigned into P. So P is pointing at K. It means that the value of P is the address of K. Then Q, which is an int pointer, gets the address of P. So Q is pointing to P, not the address of P, but it's pointing to P. By saying pointing to P, it means the address is there. So Q is pointing to P, and P is pointing at K. Does that make sense? You want to see it on the board? You want me to draw a picture of it? Yeah, probably a good idea. Of course, this great room is very, very large, but it doesn't have the basic things like a board. It has a screen, but it has a very small board. So I'll see if I can squeeze it in here. I can always manage to do it. Don't worry about it. Okay, so you can think of, it would be nice to have a little sideboard here, but that's too much to ask. So what we have here is we have K. So what we will have is we will have K here, and K has the value of 7. Does that make sense so far? Now I'm putting them in different order. Then P is another location. So P is another location, and it's at. So again, let's make believe this address is 4,000 for the sake of argument. So therefore, the value of P is going to be 4,000, and of course P is going to be maybe at 4004. This is a 4-byte location, and then Q. You can think of Q as another identifier. In this case, it's an int star star, and the value of Q is the address of P, and the address of P is 4004. So that's what it looks like in terms of memory. So when you do a cout, of, let's say, K, what prints?
7.
So you're going to print 7. Why? Because that's the pure value. When you do a cout of P, which is a pointer, you're going to get the value of the pointer. That's going to be 4,000, which is the address that it contains, because P is not a pure value, it's an address value. So when you print out P, you'll get 4,000, but probably written like 0x and a bunch of hexadecimal digits, right? When you print out Q, what do you think you're going to get? Q is a pointer to pointer, so it's an address of a pointer. So when you print out Q, you're going to get 4004 written as hexadecimal value. Are you with me? So basically it makes sense. You print out K, you get 7, print out P, you get... So these are just pointers. Now, if we want to put something in front of it, if we, instead of printing out P, we print out star P. So if we print out star P, what we're doing is we're dereferencing P, which means we go to P, which is an int pointer, and we're dereferencing, which means we're going to this address and taking the type at that address. So since P is an int pointer, star P is an int, Therefore, we print what here?
7.
7. If I print not Q, but if I print star Q, then what I will do is Q is an int pointer, so when I dereference it, I get an int pointer. So therefore, star Q goes to here. And when I go to here, what type is star Q? Star Q is an int pointer. What will print out? 4,000. 4,000. It will be the value of what Q is pointing to. Q is pointing at P. The value of P is 4,000. So if I want, what type is star Q?
Pointer.
It's an int pointer. So if I do another star in front of it, I now turn the int pointer into a pure value int. So that will print out 7. So notice that I can put 2 stars in front of Q, 1 star in front of P. I cannot put any star in front of K. Why? Because K is a pure value. You cannot put a star in front of a pure value. You can only put a star in front of a pointer variable. So therefore, the star value of P is equal to 1, star value of Q is equal to 2, star value of K is equal to 0. Notice that I can put a single star in front of Q, but the most stars I can put in is 2. Because once I go star star Q, I am now at an int type. This is an int star star. If I put a star in front of here, it's an int star. If I put another star, it becomes an int. So once I have an int, no more stars, so the maximum stars for Q is 2. So star values here are, and it's kind of obvious from the definitions here, Q is 2 star. Now, it's easy because these are variables, but we'll have expressions that also have star values. So we start easy, then we get a little, we go down a little slippery slope. Okay, so star value of Q is 2, is 1, is 0. And you understand this, and so what's going to print out here, according to our map here?
7.
That's going to be 7. Excellent, okay, very nice. All right, so now, very, very important thing in C++ is the order of operations. And the order of operations, there's a couple important things in it. Number 1 is the order of operations, which means top and bottom hierarchical setup. And the second part that's also equally important is association of the operators. And we'll talk about that a little bit later. Association means do they go left to right or right to left. So the first thing we have is, in C++, we have primary operators. Primary operators are the operators that the compiler looks at and looks at them first. So we have parentheses for grouping expressions. We have brackets typically for indexing arrays. We have dot for field selection or for method selection from structures or objects. And we have a little arrow thingy that's also a way to get something out of a pointer to an object. So these are selection operators. They select from an object. You select from an object, and here you select from a pointer to an object. So if you have an object, you can use dot. If you have a pointer to the object, you can use arrow. So they are both selectors. And then bracket and parentheses. After the primary operators, we go to what are called unary operators. And unary operators are operators that only take a single operand. So plus plus is a unary operator, because you can use it like, and you've seen this before. For example, I can write J++ or M++ or ++K, right? How many people are familiar with the plus plus operators from C# or from Java, right? Yes? Anybody not familiar? Anybody not familiar? Don't be afraid. So, and of course, minus is similar. Now, if we put a plus plus in front of a variable, it's called pre-increment. If we put plus plus after the variable, it's called post-increment. And likewise with a minus, we can have pre-decrement and post-decrement. And of course, they behave a little bit differently. How differently is very important for us to know, and we'll come back to that. Other unary operators are this one here, which is what operator? Louder? Well, destructor is not an operator, but that's a great answer. So tilde is basically a bitwise not. It takes all the bits in the memory locations and switches the ones to zeros, zeros to ones. So it's a bitwise not. It knots the bits. This is a not, but it's a logical not. If it's true, it's false. If it's false, it's true. If it's true and we put two nots in front of it, then it's not true. Which is true. If I put a not in front of that, it's false. Put another, you get the idea. All right. Here we have a minus. This is not a minus b. This is minus a, minus x. It's a unary minus. It means you're negating the value of whatever follows it. Ampersand, this is a bitwise AND. And we'll talk about all these operators. Bitwise AND is not a logical AND. It's a bitwise AND. You're taking the bits of two operands and you're ANDing them bit by bit. So 1 and a 1 is a 1. 1 and a 0 is a 0. 0 and a 1 is a 0. 0 and a 0 is a 0. 1 and a 1 is a 1. So you do it bit by bit. You don't care about the whole number. You're not adding the numbers. You're just comparing bit for bit. No carries, no nothing like that. Okay, and then we have star, ampersand and star, where ampersand is what? What operator is that? Starts with the R-E. The reference operator, and star is the or dereference operator. So it's the reference operator, the address of something, is the dereference operator. Also, some of you said address operator, and I can't really disagree with that. It can also double as an address operator. If something has an address, you can put an address in front of it, and you'll get the value of that address. Okay, so after our primary operators and unary operators, we'll come to our binary operators. Binary operators take two operands. So we have multiplication of two numbers, division, modulo, addition of two numbers, subtraction. Notice that these are higher level. All unary go above all binary. All primary go above all unary. So if primary, unary, now we're down to the binary operators. We have multiplication, division, modulo, plus, minus. After that, we have these operators called the shift operators. So we have right shift, left shift operators. Okay? Then we have relational operators. Less than, greater than, right? Equal to. What is this? Not equal to. Then we have, did I already have that one? Oh, this is the same operator, but this is actually the bitwise AND. So bitwise, this is the bitwise AND. So I kind of made a little mistake there. So this shouldn't be the AND. This is not the AND operator. This is used as a unary operator. And so it's a reference operator. But now it's being used here as a bitwise AND. This is the bitwise XOR. This is the bitwise OR. These are logical AND, logical OR, conditional operator. And then finally, these are called assignment operators. The simplest one is equals. And all the other ones are called compound assignments. Plus equal, minus equal, star equal, slash equal, modulo equal, shift equal, blah, blah, blah. Okay, so all these operators have a meaning, and the last operator, it's an operator, is the comma operator. Why is the comma on the bottom? Because it's the least important operator. What does that mean? It means that the compiler will do it last. It will do everything except for the comma. So if you have an expression here, you have an expression there, and they're complicated, and then you have a comma, it'll do all of this, it'll do all of that, and then it'll do the comma. What does a comma do? I don't know. Do you? Well, you should know, right? So I do know, and you will know. It's a very simple operator, but it's an operator. Now, what does an operator do? What's the object of an operator? The object of an operator is to do something, and then what? No. What an operator does, it returns a value. An operator returns a value. In fact, all of these operators here return values. All of them. Including the assignment operator, including all of these operators, and we need to know what exactly is being returned out of every single one of these operators and which one is being applied first. So this slide right here basically gives us the order of operators in terms of highest precedence to lowest precedence from primary, unary, binary. Now this one is kind of a funny one. This is really a tertiary operator because we have condition, question mark, value, colon, value. How many of you know that one? It's used in Java. I think C# also uses that conditional operator. Not sure if it does. Okay. So, and then these are the assignment operators. Okay. So lots of things. So let's take a look. So why do we need to know all this stuff? So basically, we need to be able to get the value of this expression. So we have an expression like y is assigned z plus 2 minus a slash k star b plus y. So the point being here is that you need, if I gave you values for all these variables, maybe except for y, you should be able to give me the exact value that's going to be assigned, and you can't be wrong. Or you might say, well, wait a second, I might get two different answers depending upon the compiler. This compiler might do it this way, that compiler might do it that way, because it's not specified by the C++ standard. All right, so let's take a look at something like that. So this one over here, not behaving very well. It wants to stop right here. Very tough. All right, so I can try to write this again. Here. So we have y is equal to z plus 2 minus a slash k star b plus y. Can you all see it? Is that a yes? All right. Now, so which of these operators do you think we would do first? Do you have any primary operators? Dot, star, parentheses, brackets? No. Do we have any unary operators? Okay, so we have, but unfortunately Professor Dichter was purposefully ambiguous, and he wrote b plus y. I don't know if he means b plus y or b plus y, because that would be different, and the reason it would be different is because b plus would actually assign a value to b that would change it, and plus y would actually change the value of y. And that's called a side effect. A side effect is if part of an expression changes one of the things on the right-hand side of an assignment, called a side effect. Of course, we're expecting this value to be different than it was before, right? Because something is being assigned into it. We know this operator, this equal operator, is the lowest of all the operators here. Because there's no what here? There's no comma, right? All right, so what happens is the compiler looks at this and says b plus, and it says that's okay, because basically, first of all, compilers, these marvelous things that we used to study and now we don't. Actually, the first thing they do is they look at this thing and they break this thing up into a symbol table. And they say it's an identifier, operator, constant, operator, identifier, operator, another operator, operand. Do you understand what I'm saying? We could have a semicolon here. By the way, semicolon also is an operator. I forgot about that one. So basically, what do you think is the operator? Is it b followed by plus and then plus, or b followed by plus and then plus? Do you think it's a double plus or a single plus? Well, you have to have a reason for saying what you're saying. So here's how it works. If the compiler sees that this is an identifier and this is an operator, then this is an operator. But if it sees that following it is another thing that makes this into an operator, then this becomes the operator. So plus is the operator following the b. And then this becomes another operator, and it becomes this one, and then you have the semicolon. Okay, so what happens first? So clearly the highest priority operator is what? Plus plus, isn't it? Why? Because it's unary. So what happens is the plus plus operator does this. It actually changes the value of b by assigning b one higher value than b was before. So if b was 5, then b goes to 6. If b was 0, it goes to 1. If it was -3, it goes to -2. However, this plus plus is an operator, which means it returns a value. So this right here is the value that's returned. And the value that's returned is actually exactly equal to b and not b plus plus. The value is b. Now why is the value b? And the reason the value is b is because it's plus plus. Post, not pre. Okay, so now our operators are plus, minus, slash, star, and then another plus. So what's most important? So at this point, we can evaluate this, right? So it's going to be a over k. That's a value. Now we have multiplication here. So we have division and multiplication. How do we evaluate them? Left to right. Why? Because that's how they associate. I didn't tell you that before, but now you know. They associate left to right. So if there are two operators on the same precedence level, like star, modulo, division, then it's left to right. But if they're higher, the higher goes first. So we go left to right, and now what's next? So this is going to be a over k divided by b. That will return a value. Now we're left with operators plus, minus, and plus. Those are the same or different priorities. So we go by what? Associativity. How do they associate? They associate left to right. So we're going to have z plus 2 will be a value. Now it's going to be another one, so it's going to be this right here. Okay? That's going to return a value. And then we're going to add it to y, and that's going to return a value. That value will now be acting on the assignment operator. It will assign that value into y. But the assignment is also an operator, so it's going to return a value. Which means that all of this is an expression which has a value. So if I were to say C out of this, it will print out that value. It's a value. So if I say C out, it will print it out. If I say, for example, C out this plus 2, then what's going to happen is it's going to add 2 to it, and then it's going to assign it, right? And actually, it's going to assign that original one, but then into C out, it's going to assign. It's going to do it correctly. I should do it like this, right?
Mm-hmm. Yes.
If I put plus 2 here, it's going to get a value. But basically what I want to do, if I put this here, that's what I want to do. So plus 2. So now it's going to assign this value into, right? But the C out will take, so this is another operator, which is the output operator. Okay? So we're forcing, by putting this into parentheses, to get evaluated and assigned first. So it gets evaluated, then we do the plus, and then we finally go to the output operator, which is going to be doing this. Now, so what happens is, we're going to add 2, and that's going to give me a value, and then I'm going to see out that value. Right? When I see out that value, this also is an operator which returns a value, so there's another value here. So as we see out, there's something being returned. This is value of the expression. It just continues evaluating. Now, if I put a semicolon here, a semicolon is an operator. Again, very, very low-level operator. I think the lowest of all. It's just going to be below even the comma. And what it will do is whatever value this is right here, it will simply throw it away. So the value of the expression at the semicolon time is thrown away. Now, at some point in time, of course, y will change to a different value. And at some point in time, b will also change because it's having a side effect. And the side effect is the fact that it's being modified by the plus plus that's following it. So what I'm showing you here right now is called a parse tree. So we're parsing the expression according to the operator precedence and associativity. Now, some operators, as you saw, associate left to right. Many of them do. But some operators, especially unary operators, associate right to left. So for example, let's say we had something like this. Let's say we have something like this. So let's say we have y. What is the value of this expression? What do you think is the value of this expression? What type? Okay, it's going to be Boolean. It's either true or false. Y equal to 3. So, okay. Now let's say, so that's either what? True or false. So therefore, if I have this, yeah, so if this value, for example, is true, I'm just going to put, for the sake of argument, I'm going to put a 1 here. Because that's what C++ would do. So therefore, if I put a not in front of it, what do you think that expression would be now?
0.
0. So if I say C out like this, what do you think would be output?
0. 0.
What do you think would be output? Anybody?
0.
Nothing? Garbage?
No, 0.
Rubbish? Trash? First of all, you should ask yourself, first of all, you understand what expressions are. We're very excited about the fact that we learned expressions are always ongoing in C++. That's a very exciting idea. And expressions do kind of just keep rolling around until we throw them away, like with a semicolon. However, there are two things important about expressions. Number one is what is their value, but equally important, what is their type? So this guy's getting bonus points all day long. Okay, what is their type? So if you look at y equal 3, what type is that expression? Boolean expression. And when I put a bang in front of it, that's called a bang operator, exclamation point. When I put a bang in front of it, what type is that?
Logical.
It's still Boolean. So now what's going on here is that Cout is using this as an input, using this operator. And so this is basically looking at the type of this expression. I know the value is 0, but it's not like a pure number. It's more of a true-false. So it interprets that as a false. So when you output like this might actually give you an output of false. Some compilers will output a false. Some compilers might put a 0, but the type is Boolean, and so the value should be false, because that's the type of the expression. Now, so far so good? Now, after the Cout is done, this also returns a value. Now, what value is returned here, I cannot tell you yet, because it might be too scary for me to tell you that, but there is a value here. We'll come back to it very shortly. So there is a value that's rolling around right here. Of course, if I put a semicolon here, what happens? That's going to get thrown away, whatever value that is. All right, good enough. So let's take a look. Continue. So we understand expressions have values, but they also have types, and that's very, very important. All right, so y equal to b++, this is y. So how many operators do you see here? We got 2 operators, right? So we got 2 operators. We have the assignment operator and plus. Which one is more important? Plus. So what will the value of y be immediately afterwards? B. Okay, what will the value of y be immediately afterwards? B plus 1. Now, when will b increase? B will increase. Now here's the tricky thing. Nobody can answer that question because it's too complicated. When will b increase? And here's the absolutely correct answer. But it will mean nothing to you, but it's absolutely the correct answer. B must be increased no later than at the arrival of the next sequence point. That's the standard. That's a C++ standard. Now, so of course we want to know what? What the heck is a sequence point? Oh, you want to know what a sequence point is? Okay. So now look how imprecise that is. B must be increased no later. The value of the expression B++ will be B. But B must be increased no later than at the arrival of the next sequence point. No, that would be too easy. Then we wouldn't call it a sequence point. So a sequence point basically is a bunch of different things. Sequence point could be a bunch of different things. For example, some operators are also called sequence points. One operator at the sequence point is a comma operator. Comma operator is a sequence point. Semicolon is a sequence point. Parentheses are a sequence point. So if I have to come out of the parentheses, I got to increase B by 1 before I go outside of those parentheses. If I go past the comma, I have to bump it. If I go to a semicolon, which means I'm going to the next statement, I have to bump it, whichever one comes first. So it's not so complicated, but who would ever know that? And that could give us some problems. Now here, you can see I'm omitting semicolons on purpose just to show you expressions, because I'm not writing code, I'm writing expressions. So you can see over here, this is a very simple expression. If I were to put a semicolon here, then it would be B++ value assigned into Y, return, sequence point, boom. Right? Or we could do B++ returns the value of B, store it in a register, bump B, assign the old value into Y, you're done. It doesn't matter. And again, the choice there is what are the machine instructions actually going to look like. Okay, here are very, very similar. Now here we have an error, and I said the error is L value error. L value means, what's L mean? L means left value. Left value sounds complicated, but all it means basically is the value of the left-hand side of an assignment. Guess what they call the value on the right-hand side of an assignment? So you're geniuses, you didn't even realize how smart you are. We have L values and R values. If you look over here, for example, Y is on the left-hand side of the assignment, which means that we think that Y has an L value. So let's talk about L value. L value is called a left-hand value, but more specifically, it means if an expression, and I'm using very careful language here, I didn't say a variable, I didn't say an object, expression. If an expression has an L value, it means that there is an address associated with the expression that can be stored into. Which means if the expression has an L value, it can occur on the left-hand side of an assignment. Are you with me? Okay, so now what we're going to have is if we have Y equal to plus plus B plus plus, the reason I'm calling it an error is not because the runtime system is going to have a problem with it. The compiler is not going to pass this. This is not a legal expression. And let's see if we can make some kind of sense out of that expression. So in this expression, what we have, Y equal to B plus, let's see if I can just do it here. You guys tell me if you can see it. You can see it, right? So we have Y, I forgot what it was, Y equal to plus, plus, B, plus, plus, right? So remember, B the compiler. Compiler, the first thing that the compiler does is called tokenization. It tokenizes the statement to see what the tokens are. So it says you are an int identifier, you are an assignment operator, you're a plus operator, you're a plus plus operator. So this is an operator, you're an identifier, and you're a plus plus operator. So then what it does, it tries to do something, and so the first operator is what? The first operator is plus plus B. By the way, there is, or actually I think it's the other way around. I think the post plus plus is a tiny bit higher than the pre plus plus. Look it up. I'm telling you. So if that's the case, then this is operator. So what's going to happen is the parse tree would have to look like this, correct? And what's returned here, what this one returns is the value of B. But this operator is next in precedence. We'll try to assign it to here. But this is a value of B, and it doesn't have assignment properties, therefore there's no L value. B++ returns the value, the pure value of B. And the pure value of B does not have a memory associated with it. B does, but not B++. It's a different expression. B has an L value. B++ is an expression, that value is here, and that does not have an L value. So therefore, this will be an L value error. And you'll see it when you compile it. L value. Like, what the heck is an L value? Well, now you know. Now, what is an R value? R value is anything that can be evaluated and placed on the right-hand side. So if you think of it, if you have a very silly statement, and I think I have one coming up soon, maybe I'll make a point on it. So if you want to find out whether something is a legal statement in C++, parse it. Parse it. And I think I'll have you do that on Wednesday. We'll have a little in-class fun. All right. So L value and R value. Expressions can have one or both values. For example, A is assigned A. Now, a lot of us probably wouldn't write this line of code because it looks a little bit useless. Why would I want to assign A a value of A? But I put it there not because it's useful, but to distinguish the fact that not only can A have an L value, it also has an R value. And the compiler decides which one it's using. If you think about it, it's an obvious statement, but what it's doing is not obvious. It's going to the address of A, fetching the value of A, and storing it into the address where A has allocated memory. So the L value of A is its address and type. And the R value of A is its pure value. So the R value of A is very similar to B++ being the B++ is the R value of B++, which is B. But not from the assignment standpoint, only from the pure value standpoint. So, what does this mean 5++? So is 5++ correct? So if it's correct, for example, I would have to have an arrow from here into 5 and returning a value. So does that make sense? Because basically you understand that the ++ is what kind of operator? It's really an assignment operator. It's an increment operator. It is a side effect operator. It changes the value of its argument. So therefore, this is changing the value of, okay, and this one is trying to change the value of, okay, I'm changing the value of 5. Now all 5s are going to be 6s. Do you like that? So when you use a 5, you'll get, no, this is wrong. Because 5 does not have,
Left
5 does not have what?
hand L value.
An L value. So just like you can't say 5 is assigned 6, I hope. You can't say 5++ either, or ++5. Notice that I have only one R here. That's a little joke. All right, I know you don't believe me. But, so now we're going to look at bit operators. Bit operators are fun. So bit operators operate at the bit level. They don't care about the wholeness of the number, whether it's an integer, 2's complement, whether it's an IEEE floating point number. They just look at bit for bit, and they work on integer types. That means they don't work on floats, they don't work on doubles, they don't work on long doubles, they don't work on any doubles or floats. But they work on all other types of primitives, like int, short, what else we have? Char, long int. All right. So 13 looks kind of like this, and for the reason now 13, if I is an int and it's equal to 13, more than likely it's going to be a 4 byte. It's probably going to have like 32 zeros and ones. I'm just looking at the tail end. All these are other zeros and then 0, blah, blah, blah. So 1, 2, 4, 8. That's 13, right? And then I have 124. Well, you're going to have to trust me here. This is 64, 32, 16, 8, 4. Add them together, 124. Or if you don't trust me, you understand this single one is 128. So that means all of these are 127 minus 3. Remember that last time? That's a 124. So now, I'm going to do a C out. So now, when I do a C out, I'm going to look at... This is an expression, by the way. We can parse this expression. This is not special code. This is just an expression. Which operator is highest precedence here? The ampersand is highest precedence. So it's I and J. What type of an operator is single ampersand? Bitwise AND. So what it's going to do is going to take every pair of corresponding bits, the yellows, the non-yellows, yellows, non-yellows, like this, and it's going to AND. So basically what we're going to have is 0 and 0 is 0. 0, 0, 0. 1, 1, 0, 0. Get it? So therefore, the two ones are going to be 1, 2 in the position of 8, in the position of 4. So therefore, when I output this thing, it's going to output whatever is the result of this expression, which happens to be a numerical value of 12. It's going to output 12. Does that make sense? James? Okay, because what's going to happen is when you AND, now this bunch of zeros are going to be 0, a bunch of zeros are going to be 0, but the only excitement is going to be here. But the AND is going to give me a 0, 0, 0, 0. The only one is going to be here, followed by another one here. And then 0 and 0 again, because the ANDing. So the resulting value of the expression will be all zeros, all zeros, all zeros, 1, 1, 0, 0. And that happens to be a 12.
That's binary value.
That's a binary value. That's all it is, just a binary value. So that's why you're getting, but you're printing it out like a decimal.
Oh.
If you printed I, you'd get 13. If you printed J, you'd get 124. If you print I and J, you'd get a 12. Why? Because that's what the bits do. Well, James, look over here. See 0 and 0? If you AND these bits together, you get a 0. If you AND these bits together, you get a 0. 0, 0, 1, 1. Okay, so that's why now if I do a C out of I or J, that's a bitwise and OR operator. So OR is going to, again, all the zeros here are going to give me 0, but then this is going to be 0. Now I'm going to get a 1, 1, 1, 1, 1, 0, and 1. And so the output is going to be 125. If you add up all those ones that get ORed in together, you're going to get a 125. And one more operator is called the XOR operator, which is this one right here. So the XOR operator, if I did, for example, output C out I XOR J, XOR is exclusive OR, it will give you a 1 only if the bits are different, 0 if they're the same. So I would get 0, 1, 1, 1, 0, 0, 0, 1. Whatever the heck you get, that's what you get when you print it out. Just an expression. Okay, so what do you get from the C out of 3 and 8? Bitwise. So think about what a 3 is, think about what an 8 is. 0. Because the 3 is going to have a 2 and a 1, and the 8 is going to have just a 8. Nothing's going to line up. So one of them is going to have a 0 everywhere. So it's going to be a 0. What if you did the output of 3 or 8? Say again. You get 11. Because the 8 doesn't have a match, so it goes in, and the 2 and the 1 don't have a match, they go in, so you have an 8, a 2, and a 1, which makes 11. It looks like it's adding. It's really not adding it. How about if I had 3 ampersand 7? What would I get? 3 ampersand 7. 3. Because you have 4, 2, 1 is a 7, and a 3 is 2, 1. So the 4 gets ANDed out, and the 2 and the 1 stay 3. Okay? And here we have XOR 3 and 8. So what is this going to give us? That's going to give us 11 also, because the 2 and the 1 are only appear as 1s in one of them, and the 8 appears as 1 only in one of them. So all of them will stay on. Everything else is a matching set of zeros, which will be 0. All right. Awesome. Now, other bit operators are so-called shift operators. So shift operators are very, very useful, and especially for C and C++ programmers, because they are very, very fast compared to other operators. Because basically, if you're looking at a CPU and you're looking at the ALU operating inside the CPU, and if you have something inside a register, a shift operator is extremely fast because it only works on one operator and just moves the bits either this way or this way some number of times. So shift operators are much faster than addition operators, than multiplication operators. They're very, very fast. For example, multiplication might take up to 8 clock cycles on the CPU, but a shift might be able to be done in one operation. So if your processor is running, for example, at 3 gigahertz, you might be able to make one shift operation in one billionth of a second. But a multiplication might take like 8 or 9 billions of a second. So it's a lot longer, especially when you're doing them continuously. So if you look at 15, imagine what a 15 looks like. Well, a 16 is a 1 over in the 16ths. So that means if I put a 0 here and I put all the other ones, I'll get a 15. So a 15 is 1, 2, 4, 8. So if I take that 1, 2, 4, 8, and I shift it to the left by 1, the 1 goes to 2, the 2 goes to 4, the 4 goes to 8, the 8 goes to 16. Effectively, every single bit is now twice as big as it was before. So what happens is, this expression is now 30. And that's what I output. When I output it, I get 30. So effectively, shifting to the left by 1 could be multiplication by 2. What if I shift it again by 1?
Multiplication by 4.
It's another multiplication by 2, so it would be multiplication by 4. Okay. So we expect to get a 30 here. So the question is, why would anybody ever multiply by 2? Well, you got to be careful. Okay, because what happens is, if you have a number, and now remember, if you have 32 bits and you have a 15 here, that only has a 1, 2, 4, 8, so you can shift it. You can keep shifting it many times, but eventually, if you shift it too far, you're going to get that 1 going into the sign bit. When you go into the sign bit, all of a sudden this number becomes negative. So if you have big numbers that have big, very high bits close to the sign bit, if you shift over that sign bit, all bets are off. So a lesson is that if you want to multiply by 2 or by 4 very, very fast, or if you want to multiply by 3, you know what you can do? You can shift by 1s and then add it to the original. That's a multiplication by 3. For small numbers, it's super fast, much faster than multiplying by 3. But you have to know that you're operating on small data. If you don't, then you could be going into crazy area. Where people say, what the heck is going on over here? So is shifting a substitution for multiplication? No. But it can be used sometimes for that reason. Now, in this case, what I'm doing is I'm going to shift to the right. So again, imagine 1, 2, 4, 8. So now I shift to the right. The 8 goes to 4, the 4 goes to 2, the 2 goes to 1, the 1 goes into the bit bucket. The bit bucket, a little garbage bucket for bits, very tiny. So what happens to this number? What's 15 right shifted by 1? What's the value? It goes to 7. So it acts like truncating division. How about if I had 16 right shift 1? 8. How about if I have 24 right shift 1? 24 right shift 1. 24 is 16 and 8. So it goes to 12. So they got 8 and 4. How about 12 right shift by 1? 6. How about 6 right shift by 1? 3. How about 3 right shift by 1? 1. How about 1 left right shift by 1? 0. Get it? Okay, so now what if I have 15 right shift by 3?
1.
15 right shift by 3.
1.
So it's going to be 1. Okay, good. All right. Now, let's take a look at this code. Let's take a look at this code. I want to explain this code to you. First of all, what is this?
1.
What's long? Long int. What's a long int? Long int is typically twice as many bits as an int. If an int is 2, this may be 4. If an int is 4, this may be 8. Get the idea? Is it standard for C++? No, it's not standard in C++. It's different between different compilers, but generally speaking, nowadays, a lot of times it's 4 to 8. So 8. Now, 8 means let's, for the sake of argument, assume that it's not going to be 8. Let's assume it's going to be 4 bytes. Now, what is 0x? 0x is a prefix for hex constants. Hex constants. So how many people understand what is 0x8 followed by these zeros? How many people understand this notation? But what number is this? And I don't need you to tell me the actual number, but I need you to tell me what it looks like. First of all, let's count the number of digits here. 1, 2, 3, 4, 5, 6, 7, 8. You got 8 of these. How many bits is the number? I have 8 of these things after the x. 8 of these things. So how many bits? The answer is every bit is a hex bit. So every hex bit corresponds to 4 binary bits. So this is a 32-bit number. Each of these numbers is 4 bits. So this 0 is 0, 0, 0, 0. So is this one. All of them are. But this 8 is from the left side to the right side, 0, 0, 0, 1. 0, 0, 0, 1. You have 1, 2, 4, 8. So this number, if you were to unpack it into binary, would look like a 1 followed by 3 zeros, and then it would have 28 more zeros. So we can think of this number. I don't even know what number it is. By the way, it's a negative number, FYI. It's a negative number, but I don't care about it because I'm not using it as a negative number. If I were to output it, it would be negative. But I'm not using it for its sign. I'm using it for its bit placement. So what I'm going to do is I'm going to say int n equal to 0, k is equal to 32767. Do you know what number this is? Anybody recognize the number 32768? 32,768 is also known as 32k. 32k is 2 to the 5th times 2 to the 10th, which is 2 to the 15th. That's 32,768. So therefore, 32,767 is 1 less than that. So therefore, it's going to be all ones prior to that 32,768.
14.
Yes, so think about it. Look at the numbers. You have 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, K. 2K, 4K, 8, 16, 32K. So the 15th bit makes it 32K. So if I turn that to 0 and turn all the 14 on, what am I going to have? I'm going to have 14 ones, followed by the rest of them being zeros. Okay? So now what I'm going to do is I'm going to loop 32 times. And what I'm going to do is I'm going to discover the values of the bits that I have in that number K. So what I'm going to do is I'm going to write this code. N plus equal M ampersand K question mark 1 colon 0 semicolon. Now that looks like a nice C++ code. And what that means is most people don't understand what the heck is going on. Okay, so let's find out what's going on here. So the first thing we're going to do is plus equals is an assignment operator. It just means that N is equal to itself plus this expression. So really what we need to do is we need to find out what is this expression. And this expression has two operators. One operator is ampersand, and the other operator is the tertiary operand question mark colon. So this is an expression, because this is a low priority operator, and this is also very low, even lower, this is the first thing that happens. So we have this question mark 1 colon 0. So basically, now whatever goes in front of the question mark is evaluated as a true or false. Now, in order to understand what is true false in C++, you have to understand how C++ looks at true false. C++ looks at anything that's non-zero as true. So if you say if 5, that's true. If you say if -8, that's true. If you say if 0, that's false. If k is equal to 1, and if you say if minus minus k, that's false. But if you say if k minus minus, that's true. Follow what I'm saying? So m and k is a bitwise AND. So it's going to line up m, and you know what m looks like? 1 followed by 31 zeros. And you know what k looks like? It's going to look like 17 zeros, or 18 zeros and 14 ones. And what's going to do, it's going to say m and k. M and k. Keep in mind that the value of m is going to be 31 zeros. The only bit that's going to be on is the high bit right here. Everything else is zeros. So the only way that result is not going to be 0 if this number k has a 1 in the high bit. Does it?
No.
It does not. So therefore, m and k will be equal to, that will be 0. And 0 will be interpreted as a true or false? False. Therefore, if it's false, it's not true. 0 is the return value, and that's being assigned into n. So we add it to n and assign it into n. Plus equals means add them and assign it into n. Add them and assign it. Yes?
So what is that inside of a loop?
Well, you're going to see that momentarily. Okay, so everybody understands. So right now, n, which starts at 0, is equal to itself plus 0, so n is still equal to 0. Now we go m right shift equal 1. Right shift equal 1 means what we're doing is we're doing m is right shifting by 1, and we're assigning that result of that expression into m. Let me show you what it looks like on a parse tree. So in a parse tree, if we have m right shift equals 1, okay, this is how we parse compound assignments. Plus equal, star equal, blah, blah, blah. Okay, the first thing we do is we do m right shift 1. That returns a value. That's going to be m right shifted by 1 bit. Then that value, whatever it is being assigned into m and then returned as part of the expression. So it is changing m by 1 bit. It's an easier way of saying it rather than m is equal to m right shift by 1. Very common. Okay, so now when m right shift by 1, what does it do? Remember what m was? M was 1 followed by 31 ones. But now we're saying m right shift equals 1, so what happens is it gets right shifted by 1, which means that 1 in a high bit goes to the second high bit, and now we have to import another number here, that's a 0. So what we have now is we've moved that 1 high bit into the second position. And when it moves in the second position in the loop, we now are going to say n plus equal. Now we're doing m ampersand k, and we're trying to find out whether that 1, which has shifted to the right by 1, which is the only one on m, is going to line up with another 1 in k. And will it? No. And the reason, because we have about, what do we say, about 18, we have about 18 zeros in k before we start hitting those 1s for the 32, 7, 6, 7. So so the reason it's in a loop is we're trying to accumulate into n the number of 1s we have. And we keep taking that m value and shifting it by 1 each time, so that the 1 in the m is here on the first iteration, then here, then here, then here, then here, and here. And every time we shift it, we do an AND with the original number to see whether that 1 is on. If that 1 is here, that's the only chance the result has to be a 1. When the result is a 1, what do? That means happiness, true, it's a 1. So then a 1 gets assigned into n, to add it to n, and then it's assigned back into n. So we're counting the number of 1s in k in the binary representation. Does it make sense? That's what we're doing. So what do we expect the result to be? So we expect the result to be 14. How about if k is 32,768? 1. Because that's just 2 to the 15th, which means it's a single 1 in that 15th bit. We turned it off, we put all the 14th on, that's why we knocked it down to 32,767. Okay. All right, we got it so far? Having fun yet? Okay, get back to me later. All right. So, classes. How many of you are familiar with classes? Probably all of you have heard of classes. So it's a very important concept. If you're not strong in classes or OO, it's very important that you pay attention. What is a class?
It's a blueprint.
It's a type. It's a type. It's a type. It's a type. And a type, generally speaking, but this type has 2 pieces on it, and that's data and actions. And we have, of course, lots of names for those. Sometimes we call it data and actions. Sometimes we call it properties and methods. Sometimes we call it attributes and responsibilities. We have all kinds of fancy words we can use for it, but basically a class is a type that includes some data parts and some functions. So sometimes we call actions functions. So when a function is part of a class, we typically refer to that function as a method. Or in the old term speaking, we would say that it is a member function. Member of what? Member of a class. So a member function is a member of a class. A member function is a method. What's a method? It's a function inside of a class. It's the actions of a class. So data can have these 3 different names: properties, attributes, a field. And actions can refer to methods, functions, or procedures. These are all words that mean similar type of things. A class encapsulates its properties and its methods, which are in here. So properties and methods are encapsulated. They are enclosed together. They're sealed. They belong together. Here's some properties. Here's some methods. What do the methods do? They operate on the properties. How about other methods? No, they can't. So if you're not in the class, you don't get to operate on the properties. So all these properties are methods. We call them members. So member properties and member methods. If a member is part of a class, then basically it's either a property or a method. Actions of a class can be implemented in C++ by methods, but they also can be implemented by operators. Like what? Like operators. For example, plus is an operator, so it could implement action in a class. The output operator is an operator, so it could implement the action of a class. Any C++ virtually, not any, but almost any C++ operator could be an action. These are called overloaded operators because they can perform actions that are defined by you, the programmer. This is different than C# and C++. They do not allow you to do that. It makes it very, very interesting because it simplifies the code for reading it, but it might complicate the code for writing it. So for example, if I define a class called a fraction, and I create a p as a fraction, and q is a fraction, and z is a fraction, then I can say z is equal to p plus q. And plus means add 2 fraction objects and return a fraction into z. It's very simple. The code becomes very simple, but we have to implement that plus because that plus no longer means the original plus. However, it's still parsed exactly the same way in the parse tree. The parsing doesn't change, but the meaning changes. Class qualifiers. Qualifiers means that they give you some special restrictions or special indications. Qualifiers basically could determine things like who is allowed to access certain members, access to the class's members. Okay, so class qualifiers include public. If your members are public, everybody can see them. If your methods are public, then anybody can access them. If your properties are public, anybody can access them. If your properties are private, nobody can see them except your class. Remember, a class contains properties, which are things, data, and methods. The methods can always see their properties. We're talking about what can the outside world see. If it's private, they can see nothing. If it's public, they can see everything. So typically what we do is we make our data how? Private. We hide the data, and we allow access to our methods. So the methods are often public and the data is often private. Not 100%, and there's some more levels that we're going to talk about, but basically that's the idea here. And there's another one called protected, and I'm going to get to protected. Protected means that it can be seen and accessed by some, but not everyone. So again, exactly who can access protected data, we'll talk about. So what we're going to do is we're going to spend time on discussing this very, very important class. Not very important because it's an important class, but it's an important example to really teach you how classes are implemented in C++, how we can implement actions of operators, etc., etc., etc. So we will say rational class, which is very, 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 very similar to a fraction. Basically, we're going to define a class that holds a rational number, which is integer over integer, a numerator and denominator. It allows access to the object, allows construction of the object. It will overload some operators, and it will allow for reading and displaying the object. That's what we want this thing to do. So I'm going to show you in here is going to be the beginning of what we're going to talk about. And so this is essentially the header file. I believe this is the entire header file. So this is the header file. Since the class is called rational, this header is called rational.h. So remember, this is that half of the module, right? This is the module header. And so the module header is going to show you a bunch of different things. So first of all, let's just go through this briefly, and then we're going to flesh it out in detail so that you understand exactly why I'm choosing to do certain things in particular ways. Notice that I am including IOStream for input-output. I am using namespace std, which means standard namespace. We haven't talked about namespaces, so I'm not going to talk about them now because I have a minute to go. So namespaces is something we can create. We'll talk about that later. Then here we go. Class declaration. The class keyword. Rational is the name we like. Parent or brackets, open, bracket close, semicolon. That's the end of the definition of the class. End right here of the definition of the class. Now, if the class is rational, any method that's called rational is considered to be a constructor method. So constructors have exactly the same name as the class. Now, I have another method called what? Numerator, and numerator returns an int. And I have another method called denominator, and denominator returns an int. And I then have another method called read, which returns nothing. I have a method called display, which returns nothing. I then have these things called operator equal, operator plus, operator star. These are overloaded operators. So this allows me to assign into an object. This allows me to add two rational objects, and this allows me to multiply two rational objects. Does that make sense? Okay, so what we have here is prototypes for a default constructor because I'm trying to construct a rational with no info, an int constructor because I'm trying to create a rational with a single int, an int constructor because I'm trying to construct a rational with two int values. By the way, the private property data are top is an int and bottom. Top and bottom, rational, right? That's what I'm talking about. Okay, then notice that I have down here, I have another, this doesn't look like a property, this looks like a what? This looks like a method, but it's private. So notice that everything here, all these constructors and operators are public, but all this stuff is private. What does it mean? I don't want people other than my own methods messing around with the top value, the bottom value, or calling normalize. But if you want to call this operator or this operator, fine, I'll let you do it. No problem. Now, we also have something very, very interesting. Here we have a very weird code, okay, which looks like an operator output. So this looks like our cout operator. When we say cout, and we get output, this looks like the output operator. This is operator output. But it's got some weird stuff in here. It's got some weird stuff over here. We need to focus in and then figure out what the heck is going on, because what we're going to talk about next is we're going to be talking about implementation of all of this in the CPP file, but not today. For Wednesday, I would like everyone to bring your computer. You may need it to solve some of the problems in class. Okay, so bring your laptop. And in your case, if you can't get that Xcode to work, maybe you can go online. But I trust you will get it done. Okay, any other questions or comments? Okay.